The rapid developmental timeline of zebrafish yields a tight but accelerated window to explore toxicity, behavior, and disease. Disease in particular must be studied with a developmental context to elucidate mechanisms and progression. We report the construction and validation of an assay pipeline controlled by machine learning software in which motion tracking behavioral assays are triggered by developmental classification and the transition from the embryo to larval stage. We couple this software with a novel imaging platform termed a micro-camera array microscope, or MCAM, to simultaneously image and analyze all wells in a 96-well plate at high resolution. Initially, in time-lapse mode, the MCAM captures 0.7 gigapixel snapshots of all 96 zebrafish embryos every 5 minutes, and their transition to the larval stage is qualified using a convolutional neural network. The model used in this experiment was trained with over 51,000 labeled images of embryos and larvae and yields approximately 97% prediction accuracy. When a user-defined threshold of hatched fish is reached, the next stage of our assay is triggered, which activates recurring video acquisitions and accompanying behavioral assays, yielding quantitative behavioral data. Additionally, the user is notified by email at defined checkpoints with high-resolution images, and the transition to time-lapse video acquisition can be initiated remotely. To validate this pipeline, we compared zebrafish development and behavior over 5 days and extracted quantified metrics across the full period. Combining machine learning classification with the imaging capabilities of the MCAM allows for automated, high-throughput data acquisition and analysis of zebrafish across an entire 96-well plate simultaneously. Combining machine learning classification with the imaging capabilities of the MCAM allows for automated, high-throughput data acquisition and analysis of zebrafish across an entire 96-well plate simultaneously. This can be used to fine-tune experimental protocols to specific points of the organism's development.